Okay, the base is a real number. But the restriction for the base is the base never is negative, no positive, only positive. Real number, pero positive. And no zero, and no one. Because it's trivial example. Stupid, trivial. Okay, so this is the exponential, you know, I suppose you remember. But now I want to find the inverse of the exponential. And the inverse is, remember the idea for the inverse is interchange x and y. This is the key idea for finding the inverse function of the any function. So x is equal a to the y, something like that. Wow, easy. But the problem is, okay, this is the inverse. Okay, I understand very well. This is the inverse. But this inverse is implicit. Implicit form. Remember, the implicit is not nice. The implicit is confusing. I need explicit, it's clear. So what is explicit when the y is isolated? So I need y alone. Okay, entonces the notation, no problem. Okay, Victoria said, no problem. Thank you, Victoria. To isolate the y, you put a y here. So you define a new function. Okay, the name of this function is log, three-letter log. Entonces you put a small number here to indicate the base, que the base is a, and of the argument is x. There you go. And this is the logarithmic function. Okay. So this is the definition, but maybe you don't understand very well the idea behind the logarithm, right? So now let's move on to the interpretation. Interpretation. Pay attention now. Interpretation. What means logarithmic function? Interpretation. Okay, interpretation. Suppose we have two different kinds of statement. Suppose exponential statement. Okay, you are very, very familiar with the exponential statement. Suppose 2 to the fifth power is equal to 32 because 2 times 2 times 2 times 2 times 2, 5 times is 32, no? 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, 16 times 2 is 32. So this is clear. Now I want to change this statement to exponential statement, to logarithmic, right? Sorry, logarithmic. Logarithmic. I need to understand very well what means logarithmic statement. Okay. Entonces, logarithmic statement, I suppose que you put the word log, logarithmic, right? And remember, logarithmic, you have a small number here, small number, to represent the base. In this case, the base is 2, it's obvious, right? And you put a small 2 here, to represent the base. Entonces, inside the parentheses, you put 32, get the result of the exponential. And the answer is 5. Wow. Entonces, what is the interpretation? The interpretation is logarithmic statement or logarithmic function. Give me the exponent. The exponent. The answer is exponent 5. Look at that. 5. The exponent, which you have to raise the base in order to get the number inside the parentheses. So basically is in the exponential we have base, the base, in our example is 2. We have one number that represents exponent, and the result is the answer when you put in a calculator or by hand. However, in the logarithmic statement is different. You put the log, you put a base here, a small number, the same base here, and you inside the parentheses, because this guy, you can interpret it like a function notation, no? And function notation, nobody write like that without parentheses. So the parentheses is mandatory. You put the result of the hypothetical exponential, and the answer is the exponent. Okay, the answer is exponent. Okay, the answer is the exponent. This is the interpretation. But okay, I don't care that. I want to practice more. Let's do an example, several examples, and you help me to understand it. Suppose 3 to the 4th power equal 81. Ah, it's nice because 381 is 99, and 99 is 33. Actually, we have 4, 3, 1, 2, 3, 4, and when you multiply, give me 81. Okay, I agree. I understand very well this. But I want to change to the logarithmic statement, and you put the word log. What is the base? What is the base in this case?
3.
3. You put a small 3 here. Entonces, inside the parenthesis, que es the argument of this new function que voy a estudiar today, que es logaritmo de name, is 81. And the answer always, the logarithm always give me the exponent que I need to raise the base in order to get 81. Es obvio que the answer is 4, que es the exponent. Do you understand or no? No clear, right? No clear, confusing. Ernie, clear, confusing, come on, opinion. I want to hear opinion. Clear! Hinaya always is clear. Okay, I don't got it for you, Hinaya. Another opinion. Clear, confusing? Because I want to make a test now. Now I see you understand or you don't. I want to check it out. Okay, clear. Johanna Cruz. Okay, Johanna. Let me see. Let's do it by hand. So far we have no calculator. No. Next class, yes. Today, no. Supposed to simplify the thing. I suppose que the base is 10. O sea, logaritmo, we compute logaritmo, base 10. The base is 10. Okay, it's base 10. Okay, after we see another example que no 10, pero bueno. Okay, of 100. Without calculator, what do you think about this answer? Opinion. Let me check it so you understand or you don't understand anything. Es 2. Very well. Alicia Figueroa say que es 2. Okay, super. Let me explain. Okay, intuition. 10 to the 2nd power is 10 times 10 is 100. Intuition, okay. Another possibility by hand, no intuition. Suppose I have no idea, x. I put x. In algebra, when you don't know something, you put a variable, x. And you transform this exponential, logarithmic statement, to exponential. Entonces, I ask myself, what is the base? Oh, the base is 10. What is the exponent? Oh, the exponent is exactly I'm looking for. I have no idea. It's equal the result, que es 100. Entonces, in that moment, we have one exponential equation. So you transform the logarithmic statement to exponential statement, and suddenly we can find exponential equation. And in order to express it using the common base, I know que 10 is 100, is 10 to the 2nd power, therefore imply que x is 2. Okay, we solving like an exponential equation, exactly we are doing before. And what about logarithm base 10? We continue base 10, guys, because I want to explore the intuitive idea. Suppose 1,000. What do you think about 1,000? What do you think about 1,000? Yeah? 3, es obvio que 3. It's 3. Suppose que I have no idea. Okay, it's 3. Well, it's easy because you count how many zeros we have. Well, we have out. Okay, how many zeros we have? Well, we have in this case 2 0 is the exponent is 2. 3 0, the exponent is 3. Oh, it's super easy to find. Suppose que we have logarithm base 10 or 1 million. 1, 2, 3, 4, 5, 6, 0. What is the answer of this? Huh? Help me. What are the answer of this? 5, no. 6. Alicia. 1, 2, 3, 4, 5, 6, 0. Okay, Inaya is a 6. Okay. Okay, this is easy. Elementary, kindergarten. Let me try to 6. Let me try to complicate your life. Suppose logarithm base 10 again of 10. What do you think? So we computed the logarithm today. S1. Very well. S1. S1. Entonces, en general, when you have logarithm of the any base and the number inside the argument, inside the parenthesis, is exactly the same, the base, the answer is 1. So in other examples, suppose logarithm base 4 of 4 is 1. Logarithm base 5 of 5 is 1. Okay, when it's coincident, the base and the number inside the argument is 1. Everyone understand this? Everyone follow me? Sure? We continue base 10. Base 10 of 1. What do you think? Logarithm of 1. No? Nobody? No? Okay, I understand. No problem. Okay, when you don't know, you put X. And immediately you convert to exponential statement. So I ask by myself, what is the base? Oh, the base is 10. But this is small 10, I put it like a big 10. And the exponent is, I have no idea. It's exactly I am looking for. And the answer is 1. But I know that 1 is equivalent 10 to the 0 power, because when you raise to the 0 power any number or any algebraic expression, the answer is 1. Therefore, it's obvious that X is 0. Wow. This is another important property. So this is super important property. But one important property in general is logarithm base A, arbitrary, doesn't matter. I put 10 in this example, not necessarily 10. When it's 1, it's 0. Logarithm of 1 is always 0, regardless the base. If the base is 10, or is 100, or is 1/2, it's 0. Okay. But I want to complicate more this. Continue compute the logarithm by hand, no calculator. Logarithm base 10 again, pero 0.1 decimal. Come on, help me. Try. No idea? Okay. -1. Very well, Hinaya. -1. Hinaya say -1. Hinaya is right. And -1. And -1. Let me try. Suppose I have no idea. I convert to exponential. The base is 10. The exponent, I have no idea, is equal 0.1. But 0.1, I can write like a fraction, like that, 1/10. And you try to express it like a base 10. I put -1 exponent because I know very well that -1 exponent represents reciprocal. Therefore, see, the base is the same and the exponential function is the same, it's because the exponent is the same. Okay, super. One more. No, I have a lot of before to study formally the logarithm. But for me, it's important the interpretation for the logarithm. What I'm looking for is exponent. Okay, one more example. Logarithm base 10, no Hinaya, another participation, 0.01. Another guy, come on. 0.01 now in the argument of the logarithm. -2, very well. Natalie Navarro, Alicia Figueroa, -2. Okay, super, super. -2. -2. -2 because suppose I have no idea. I change to exponential. Entonces 10 to the x equals 0.01. Well, 0.01 is 1 over 100. And 1 over 100 is 10 to the second power. But this reciprocal, entonces si reciprocal is negative exponent. So you can write like that, like a 10 to the -2. Conclusion, x is equal -2. Oh, it's easy, it's easy, it's easy. I want to generalize what is positive or negative, the logarithmic. But not now. Let's see one more example. No base 10 anymore. No. Let's switch into another to clarify a little bit our idea. Look, suppose this example. Logarithm of base 4. Logarithm of base 4 of 64. Okay? Let's try to do with that calculator. I promise, guys. I promise that next time I want to explain how we compute this using the calculator. Okay, so either way, in the real life, in the test, when you face one logarithmic problem, we can use the calculator or we can use it by hand. But today is by hand because I need to understand without calculator. Okay, entonces, help me. A3, very well. A3, Hinaya. Because x, when you change to exponential statement, we have 4 as the base. We have x, I have no idea, equals 64, but I know that 64 is 4 to the third power because 4 times 4 is 16, is 16 times 4. Therefore, x is 3. Very, very well. Very, very well. Another example. Suppose logarithm base 5. I suppose I change the base totally of the 1 over 125. I need help. Come on, guys. Try. 1 over 25 is 3. No, Alicia, no. Alicia, I agree with you. The logarithm of base 5. The 100, eh?
One over
Let me finish with Alicia. Alicia, es -5. No. Joanna, no. Okay. Guys, the thing is no guessing. Okay. Alicia, I agree with you. Okay, logarithm base 5 of 125 is 3. Yes or no? Everyone is agree or disagree? Okay, because it's the base is 5. The exponent, I have no idea. It's equal to 125, but I know that 125 we can get multiplication 5 3 times. No? 5 times 5 is 25, and 25 times 5 125. Therefore, it's obvious that x is 3. Positive 3, right? However, we have reciprocal. And what about reciprocal? What is the idea for the reciprocal when you talk about the exponent? Reciprocal is -3, no? It's -3. Make sense or no? Okay. Let me try. I have no idea. I put x. I convert it to exponential. Okay, the base is 5. The exponent, I have no idea. It's equal 1 over 125. But I know that 1 over 125 is 5 to the cubic power. And this is reciprocal of 5 to the -3. Therefore, conclusion is x equal -3. So minus negative exponent means reciprocal. Positive exponent, no. Okay? Everyone understand this or no?
Yes, sir.
Okay. One more before start the study in detail about the logarithmic function. One more, the last one, I suppose, is Logarithm base 1/2. Oh, the base is now fraction of 4. What's the answer of that? What is the answer of that?
-2.
Excellent. Very well. -2. Okay, let me prove. I have no idea. No idea. Totally lost. Negative. Professor, what the hell is that? Fraction. Yeah, it's possible. Remember, the base should be, so the restriction for the base is, this is the all real number line, for example. Infinity, negative infinity, 0 here, 1 here, important point. The base should be in between 0 and 1. Of course, do not include 0 and 1 because it's trivial, and 1 to infinity. Normally, we are working with the base 10. Oh, base 10 is here, 10. But why not 1/2? It's possible, right? Es totally illegal when the base is negative. Illegal, violation. But in between 0 and 1 is possible. No include 0, no include 1. And after 1 is possible. Okay, so I have no idea. I put x here. I convert to exponential. Okay, in the test, you are doing exactly the same. I try to explain. You put an arrow, you put 2 exponential. I understand very well the thing we're doing is convert to exponential. And the base is 1/2 raised to the something equal 4. Entonces I try to solving this exponential equation, try to find the common base. I suppose that the common base is 2 in this example because I know that 4 is 2 to the second, nice, and 1/2 is 2 to the -1, right? Reciprocal. Entonces 2 to the -1 replace, raised to the x power is equal to the second power. Now multiplication the exponent 2 to the -x is equal to the second power. And when you have 2 exponential and the base is the same, it's because the exponent is the same. -2 equal 2, therefore x is equal -2. End the story. Any question, guys? Super. Do you understand very well the interpretation for the logarithm function? Okay. So I want, okay. So now I want to study in detail this new function that we are studying. So to study formally, we need to find domain, range, intersecting, asymptote, everything you know in the another function. Okay. Like to say, I propose you do at least one graph of the exponential function. Graph, for example, graph that function, y equal 2 to the x power. I put 2 because 2 is easy to understand. After I promise I generalize to any base. So 2 to the x power. Okay. So I propose you do the chart like that. X is the main value and y is equal to the x. And we have another column get the point x comma y, and you try to plot the point in the rectangular coordinate system using decimals or by hand. No, do using decimal. Suppose 0, x equals 0. No. Wait. Sorry. This is exponential. Now I want logarithmic. Logarithm is different. What the hell is that? Logarithmic. Okay, logarithmic. Graph. Well, we can do the exponential and after logarithm. I don't know. Okay, let's go directly to the logarithmic. Logarithm base 2 of x. The chart is the same. X, y is logarithmic, and the point x comma y. Okay, super. 0. Bueno, 0 es logaritmo base 2 of 0. No. Oh, what the hell? Okay, logaritmo, no. Okay, we're doing right. We compare the exponential and after logarithm. Okay. Sorry, guys. Graph again. Pero graph who? Graph. Okay, graph the exponential. y equal 2 to the x. Que we did before, no? So we have x, we have y, que es 2 to the x, we have the point, que es x comma y. And now we are doing the exponential, because the relationship between this is an inverse is y equal logarithm base 2 of x. And the only thing you should do is interchange x and y. Okay, so in this column, I have the exponential, but in this column, the exponential. In this column, I have logarithm. Okay, now ready. Now we are ready. Suppose 0. 0x, es obvio que y is equal to the 0 power, and 2 to the 0 power is 1. And the point is the point 0, 1. This is universal point in the exponential. Entonces, what is the corresponding point in the logarithm? The only thing you should do is interchange x and y, 1,0. Okay? Because I know the logarithm of base 2, in this case, of 1 is 0. We know this property. Logarithm of 1 always is 0. Suppose now 2. 2, no, 1. Y is equal to the 1 power. Okay, it's just 2. And the point is 1,2. And the corresponding logarithmic statement should be 2,1. Because the only thing you should do is interchange x and y. And this is logical because logarithm base 2 of 2 is 1. Look at that. This is x, que es the number que I suppose que es inside the argument, and the answer is 1. Suppose 2. 2. 2 is y is equal to the second power, que es 4. The point is 2,4. And this is 4,2. Because I know the logarithm of base 2 of 4 is 2. Remember one more time, logarithm give me what exponent necessary raise to in order to get 4. So 2 to the second power. So this statement translate to the other languages like that. Entonces we continue 3, 4, 5. Okay, pero no. Negative 1. Suppose negative number. Negative 1. Y is equal to the minus 1, que es 1/2. Reciprocal. Entonces en the exponential is negative 1, 1/2. And the logarithm is 1/2, negative 1. Because logarithm base 2 of 1/2 is negative 1. Okay, do you remember that? When you are doing the base 10, que es 0.1, this in the case is no 0.1, es 1/2, que es 0.5 en décimo, ¿no? Es negative 1. Likewise, negative 2 is equal, y is equal to the minus 2, que es 1/4. Entonces es negative 2, 1/4, no negative positive. Sorry. 1/4. And here is 1/4, negative 2. Because logarithm base 2 of 1/4 is obvio que es negative 2. Okay, this is the idea. Entonces I want to plot this in the rectangular coordinate system to see. Entonces you analyze more clear graphically. One image is much better than 1,000 words. What is the domain? What is the range? What is the intersecting point? And what is the formula? No? What is the most important characteristic of the logarithm function? Look, let me show you. I want to open Desmos. I want to share that screen. Switching to Desmos. Boom. Do you see Desmos now? Okay, I remember the last time we saw, for example, this exponential. Okay, this is exponential, right? Now, today, the only thing you should do is interchange x and y. When you interchange x and y, wow, look at that. For example, the famous point, universal, que es the exponential, que by the way, the exponential is the red color, no? And the curve, que is the red color, is exponential. This point is 0,1. is the universal point in the exponential. The universal point in the logarithm is 1,0. Okay, and remember this is like an image, no? Let me see, image, reflection with the line, y equal x, que the identity function. Okay, well, likewise, for example, the point 1,2 is analogous the corresponding 2,1 in the logarithm. So the logarithmic function is the blue curve. Okay, entonces looking this blue curve, we can predict what is the domain and range. For example, looking the curve, let me see, I pay my attention only in this part. I want to predict using intuition, imagination, no? The domain. Look at that. I don't see the blue curve, que es the logarithmic function, in the negative part. So the logarithm of the negative number is totally undefined. Do not exist. And what happened in zero, specific in zero? In zero, the curve approach, but never touch. Let me make it soon. It's a vertical asymptote. Okay? Therefore, logarithm of zero is also do not exist. So what is the domain? Let me come back to the whiteboard. Whiteboard. Okay, there you go, whiteboard. Okay, super. Let me erase my whiteboard. Erase. Okay, good. Okay, domain of the logarithm. So this is a property. Properties of the most important logarithmic function. Okay, number one, domain. Domain is, remember, all real number except restriction. In this case, the restriction is non-negative. The domain is from zero, not including zero, to infinity. Okay? We can compute a logarithm, either base, doesn't matter, of 1, yes, we can, it's 0. We can compute a logarithm base A of the 220, you can. A logarithm base A of negative 2, no, do not exist. Okay, illegal, totally illegal. And logarithm 0, no, doesn't exist. You can see, now I explain, no, theoretical. But when you use the calculator, you put logarithm negative number, automatically you see in the display of the calculator error. Okay, out of the domain. Yes, means out of the domain. However, the range, no, the range is all real number because the answer of the logarithm we can find positive, negative. Entonces, what depends if positive or negative? Okay, listen to me. Suppose logarithm base 2 of the 1/2. Que you know que es negative 1. Entonces, this rule is classical. If the base is a number greater than 1, and the number inside the argument is a number less than 1, the answer for the logarithm is negative. Otherwise, if the base is less than 1, and the number inside is greater than 1. So it's the opposite. So one is greater than 1 and another less than 1. So the answer is negative 1 again, no? However, see the base is greater than 1 and the number is greater than 1, the answer is positive, right? And see the base is less than 1 and the answer is less than 1, just the answer is positive also, right? Because 1/2 raised to the second power is 1/4. Make sense? So this is not super important, but it's a clue que give me information when you compare the logarithm. So you don't expect what sign. So you put in the calculator know the rule very well. I understand it's positive or negative. So see the number is less than 1 and the base is greater than 1, so opposite, it's negative. Because maybe somehow involve reciprocal operation. When do not involve reciprocal operation because it's the same nature, the same behavior. So greater than 1, so no reciprocal. And greater than 1, and less than 1, and less than 1, no reciprocal. Okay? Make sense? It's clear or no? Another important property. Okay? It's okay? Everyone follow me? It's Chinese or it's Japanese? Or it's mathematical? English? Perfect. Eh? Say yes or no. Everyone follow me?
Yes,
It's
sir.
important. It's important to understand this because I promise I want to complicate this. Uh-huh. Entonces, okay, yes, Tico. Uh-huh. Ismael. Tico, you are Albert, no? Okay. Okay, okay, Tico. Okay, then another property is the x-intercept of the logarithmic function is 1,0, always, totally independent of the basis. So any logarithmic function passing through the point 1,0 que here, 1,0, 1,0. Suppose logarithm look like that. Look like independent of the base. And what about y in its set? No, we have no y in its set. No. Why no? Because it's asymptotically, the core is asymptotically to the y-axis, never touched. Okay, this is important property. You know, when you write or when you answer the question, do the graph of the logarithm, okay, so you are doing that way. Okay, and number four is one. Okay. Basically, if the base is a number greater than 1, the logarithm is increasing function, increasing. So far we are studying only increasing. This is increasing. Remember, increasing to determine increasing, the roller coaster goes up from left to right. Okay, I promise you another logarithm when the base, I want to prove now, when the base is in between 0 and 1, it's decreasing. Decreasing function. Okay, super. Well, very important now. Look at that. The number 5 property. What is the typical? The typical points to do the graph of the any logarithmic function. Look, the typical point are, bueno, universal es clásica, 1,0. Another guy is the base, 1. Okay, the base. So suppose in this case, we are doing the graph of the logarithm of base 2, no? So mandatory that the point 2,1 belong to the graph of the logarithm of base 2. Another logarithm of base 3, logarithm of base 3 is 3,1, right? And so on. So logarithm of base 5 is 5,1. So basically, the formula is the number of the base, 1. And another is the 1 over base reciprocal of the base, -1. So for example, in this example, the base was 2, is 1/2, -1. Suppose that the base is 3 is 1/2, 1/3, sorry, -1, no? This is easy. Let me explain now in detail now in another example. Suppose the last property is super important. Any graph of the logarithmic function contain one vertical asymptote. At x equals 0. O sea, coincident exactly with the y-axis. And this is an important part of the graph. You are doing the graph of the logarithm without asymptote. No 0, but I discount 5 points. So the asymptote is part of the gain of the logarithmic. Okay, let me try. Okay, let me try to explain a little bit more clear, a little bit more in detail the when the base is less than one, no? Okay, it's confusing, right? Or no. First of all, I want suppose in the test. So we have two important questions in the test number 4. Number 1 is do the graph of the one exponential, but I explained that. And number 2 is do the graph of the logarithm. So suppose que in the test I put something like that. Do the graph of the logarithm base phi of x. Okay. Okay, professor. I understand que the graph by hand is without decimals. We have 3 points. The universal get 1, 0. Another point is logarithm the same number phi of phi is 1. That the point is 5,1. That this point is a typical. Look at the typical. The typical is typical. Look at the formula. The formula is base, comma 1. And our example I put in the test, suppose hypothetical test, no? So probably what number you put here? Is 5,1. 5,1. Okay, 5,1 is 2, 3, 4, 5. 5,1. I plot that point. 5,1. And another typical. 1 over the base. 1/5, comma -1. Okay, because it's reciprocal. Okay, because I know the logarithm base phi of 1 over 5 is -1. Okay, entonces I plot that point. 1/5, I suppose I divide this segment in 5 portions. Suppose hypothetical is like that. 1/5, 0.2 in decimal, -1. -1. Here, I plot that point. 3 points I have in my hand. And also I know by property for the logarithmic graph that we have one vertical asymptote at x equals 0 here. Boom, 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 boom. And now I do the graph connecting this point, this point, this point, this point, this point. I suppose to travel like that. And it's asymptotical, approach but never touch. And this is the elegant graph by hand of the logarithm. Okay, of course you can do using decimals, no? But this is not the idea. Do you understand this? You say you will be able to do the graph of the any logarithmic function. Suppose that the base is 2, or is 3, or is 4, or is 20, or is 10, either way. The challenge is when the base is fraction. I want to explain in detail now. Any questions so far? Any questions so far? Any questions so far? No? No. Okay. Let's do in the graph when the base is less than 1. Okay, similar, but the only difference is decreasing. Suppose I want to make it the graph of the logarithm base 1/2 of x. It's the same. What is the only difference? Decreasing. But okay, I have no idea. Let me try using the famous 3 point. X, Y. Remember, when I do the graph of this, the universal point is 1,0. I plot that point. 1,0. Okay. Remember, another is the base, in our case, 1/2, comma 1, no? Because the reason is logarithm base 1/2 of 1/2 is obvious, 1. Because what is the exponent necessary to raise 1/2 in order to get 1/2? It's obvious, 1, no? Entonces, the point is 1/2, que 1/2 is here, the half, comma 1, comma 1. Here is 1. Here, that point is the point, 1/2, comma 1. This point is 0.5, 1/2. And the other is reciprocal of the base, que es 1/2, entonces the reciprocal es 2, no? Comma -1. Okay, reciprocal is one of the 1/2 is 2, ¿no? Flip it over. Ajá, entonces 2 es here, comma -1. Okay, this point is a point. 2, -1 belong to the graph of this. Now I know also the property can say that any logarithmic function contain one vertical asymptote here that the curve approaches but never touch the y-axis and never overcome the y-axis. So we have no function in the second quadrant and the third quadrant. No, it's stupid. Now the curve look like that. Okay, do you think it's similar? It's similar. Is the arrow continue forever? The arrow continue forever. But the only difference is decreasing because my roller coaster car traveling from left to right is going down. Entonces it's decreasing. Function. Okay, just in case, to make more clear, let's move on to this one to see exactly this example. Okay. Good. Do you see this one now? Okay, this was the previous example. This is the clear when the base is greater than 1. But when the base is not greater than 1, when the base is less than 1, okay. The thing look like that. Look. Okay. Make it zoom. Okay, make it zoom. Okay, again, one more time happen. Let me make it zoom. Wow, what the hell? Look, the red one corresponded with the exponential function. What exponential? When the base is 1/2. Look at that. Now, logarithm is the image with the reflection with the line y equals x. Let me analyze some points. Suppose the point 0,1 in the exponential corresponding with the 1,0 in the logarithmic. The point 0.5 get 1/2, no? 1 corresponding with 0.5, 1,0.5. So you interchange x and y. Okay? And you pay your attention, focus your attention in the blue curve, and this represents the graph of the logarithmic function base 1/2. And the typical 3-point that we are doing is universal 1, 0, 0.5, 1, and 2, que es reciprocal negative. And don't forget, please, the vertical asymptote. End the story. Any question? Any question? Any question? Let me ask a question now. In this moment, do you have with you the calculator or no? No? You have calculator, yes or no? You have calculator, yes or no? Yes. But what kind of calculator? No Sedano supermarket calculator. It's scientific calculator like that. Look. Okay, I have different options, different, not super sophisticated, but scientific. I strong recommend TI-30X like that. Look at that. Do you see? Scientific, yeah, scientific. I don't care the branch, que es Casio or Texas Instrument. For example, this I have this. Okay, this is a little bit more sophisticated, but it's okay. I have super sophisticated like that. This is TI 8089, but no, cheaper, no money. This is super fantastic. Okay, what is the reason I explain this idea? So everyone bring next time calculator because we are working with the calculator next time. Without calculator, you don't understand anything. Next time. Okay. Okay, let me erase the board. What's the problem, guy? When we so far, we computed the logarithm by hand, but not always is possible. No, not always is possible. Therefore, we need a calculator. But you need to understand the idea. of the calculator. So inside the calculator, we have two basic standard logarithmic. Function. This is H. We have the first one, it's called common logarithmic. Entonces, common logarithm, the supposition is que the base is 10, exactly the example we are doing. Now, we don't see the, okay, sorry. See, because I switch into my face to show you the calculator. Okay, super. Now, do you see or no? Okay. I try to explain that next class, when you bring the calculator, your own calculator, and everyone follow me because we compute the logarithm, so you need to get the same answer with me. In the calculator, we have no infinity base. We have the standards base. And the first standard that we study is called a common logarithm, in which the supposition is the base is 10. So si the base is 10 of any number, okay, the thing, the notation that we are using in mathematics is log of x, without anything here in the base. When you see that default, you suppose that the base is 10. Log alone, without specification of the base, default, you suppose that it's 10. So in the test, I compute this log. Some students, Professor, but you forgot the base. No, I don't. I suppose that you know that when the base is missing, it's because it's 10, right? This is the common. And the common are frequently using in science, chemistry, physics is using because it's comfortable, it's easier. However, in calculus, the student can need to take calculus using another logarithm that is natural. And offer another advantage in calculus. Okay, natural, the base is one irrational number, is E. And E is irrational number, is approximately 2.718. Infinity decimal, non-repeated place. Irrational. This is definition, that's it. And normally, logarithm base E of x, normally the notation is ln. Ln, when you see ln, it's because we are computed natural logarithm. This is the common logarithm. Entonces, bueno, professor, okay, I understand, but how we using the calculator in the real life? How you using calculator in the real life? Because for example, I need to compute another case. For example, at the beginning of this lecture, we computed, for example, logarithm base 3 of 81. I suppose you remember that the answer is 4, right? But suppose that the answer is not 4. Or suppose that the answer is another more complicated, I don't know. It's hard to find. Well, you can use a calculator. You can use a calculator using one famous formula that is called change of base formula. Chain of base formula. Chain of base formula allows us to change non-standard base. This is non-standard base. Non-standard base, que es 3. It's weird, the calculator can have base 3. No, it's impossible. The regular calculator have base 10 or E, natural or common. So I can use the chain of base formula. Let me explain in detail the chain of base formula. Okay, that's extremely important. Suppose here we have logarithm of the any base, not necessary standard, of the one number that I want to call x. So division, division. You convert logarithm of base b. What is b? Okay, a is the old base that we have, and b is the new base that we need to change. Of the same number in the argument divided by log of b of a. For example, suppose that this example I try to do using the calculator. I copy here. log base 3 of 81. Well, this is suppose that I make a decision to compute it using common logarithm. Okay, you press log. Remember when there's common logarithm, the base is 10. Not necessarily to write because everyone in the world understands that when the base is missing, it's because it's common, no? Of 81 divided by log of a gets 3. And you put in a calculator like that. You put log. Come on, try it. The student can have a calculator now. Don't worry because next time we practice a lot of this. log. Do you see? So the most of calculator have two keys for the exponential and logarithmic. Look, so the format for any calculator. Calculator, unfortunately, I have no image, but suppose we have two keys. This key is log. This key is lm. Now, any key contains two functions. For example, this is 10 to the x exponential. Exponential associated with the same base, and e to the x. This is exponential associated with the same base. And how you select logarithm or exponential? Well, using another key, we have maybe it's blue or maybe it's yellow, depending on the calculator, okay, it's the second. And the second allow me, when you press this second first, you select the exponential, no? When you don't press this, you select this. So what is the syntax to compute this in the calculator? Well, you press log, and do it now. Log, suppose that this is the display of the calculator. When you press this key one time, you have log. Y automatically the calculator is nice, open the parenthesis. Okay, then you put 81 and close the parenthesis. It's important close the parenthesis because the only number inside is 81. No? Division. Another way, press log again. Automatically the calculator open the parenthesis and you put 3. Close the parenthesis and press enter or equal. Boom. And the answer is 4. Exactly the same we predict by hand. Okay, this is a fantastic way. You have no excuse to compute any logarithm so far because we have this super fantastic formula that allows us to convert any base, non-standard base, to a standard base. But I have a question. Well, professor, I can select another standard logarithm, suppose ln of 81 divided by ln of 3, and we get the same answer, or no? So suppose the student, I don't know why, at the beginning prefer log. I suppose I understand it because it looks like similar to the logarithm log. And ln is confusing because ln, what is that? Well, it's natural. And natural, n is natural. So the answer should be the same. See, I using instead of log, I using lm. I don't know. Let me try. I press ln. This is my display now. I press ln. Automatically, the calculator open the first parenthesis. I put 81. Close the parenthesis. I type in this now. Division. division, LM again, of 3, and close the parenthesis, LN of 3, and close the parenthesis, enter, and press enter, que is equivalent to equal sign, no? And press enter, bam, and the answer is the same, guys, it's 4. Okay, so always, suppose that you don't see very well by hand, we can use in the calculator. What are the things we are doing? Well, you are converting from non-standard base 3, 4, 5, it's crazy, 1/2, to a standard. Que standard is 10 or E, que is the E is the Euler constant. Euler constant. Euler is a mathematical, the most famous mathematical in the history. Euler constant is equal E. You find this constant. Okay. So, do you understand very well the chain of base? Okay, let me summarize the most important property that we are using so far to manipulate the logarithmic functions. Guys, everyone follow me? I need to see opinion. Come on. Kyla, yes. Inaya, yes. All will follow me. Ernest, you are quiet. I want to hear you. I suppose you understand very well or no? We are totally lost. Robert. Okay. Victoria. Ismael. Natalie. Gary. Everything okay? Sure? Okay, good. Okay. Now, I want to study now the property. Yes, okay. Yes. The property of logarithmic. And this property allows us manipulate equation, manipulate the word problems using logarithmic. The most important, number one, we studied now was logarithm of the any base, standard or not standard, of 1 is 0. Keep in mind this. Logarithm 1, 0. Logarithm 1, 0. Number 2, logarithm of when the number of the base is exactly the same when the number of a number inside the argument is 1. Example, logarithm base 2 of 2 is 1. Logarithm base 3 of 3 is 1, and so on. By the way, logarithm base 10, what is that? And ln of e, what is that? El logaritmo, entonces intentionally I omit the base because I suppose que default, you understand que es 10, es 1. And this is the base is no specification. ln default, you understand que sí, the answer is 1. Okay? Number three. Okay, do you remember when we studied inverse function, the decomposition f and f inverse give me identity in both directions? And we studied in another moment that the logarithmic function is the inverse function for the exponential. So you put together in the composition, remember that symbol indicates composition. The composition, so put together in either order the logarithm and exponential on those each other. Okay, let me try to explain this. Suppose logarithm of the base a, entonces inside you put exponential to the x is equal to x. Guys, logarithmic and exponential on those each other. The answer is identity. Number 4, in opposite direction, suppose the exponential first and logarithm second. Same situation on those. Okay? So some book, antique book, called exponential function like anti-logarithmic because the opposite. But it's antique notation. Not today in the real life, current day, exponential, more clear. Okay, number 5. Important, number 5, number 6, and number 7. Super important to manipulate this. Suppose number 5 first. Number 5, forget about 6 and 7. Number 5 say, logarithm of the any base of the multiplication to expression I want to call m, and n is equal the sum. So you break it down like that. Like that. Okay, when you have multiplication two guys and you apply logarithm, you expand like a 2 logarithm. Oh, why no? We're doing in that direction or in that direction. In my opinion, it's more useful in that direction because we have, supposedly you have several logarithms, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and you condense it in only one. Si es plus, is multiplication. Okay, si es minus, que is the property number 6. Let's see what happens si es minus. Si es division, and minus. You put in the numerator the positive, in the denominator the negative. Okay, property number 5 allow us condensing several logarithms in only one. Depende, no? Because maybe in the real life problem we have a combination plus or minus. The number que es positive is multiplication. The number que es negative is division. And number 7 is super important in my opinion. Is when you have logarithm base a of the one expression I want to call m, why not? And we have exponent is r. So this property allow us to this exponent go to the front as a factor like that. R times log base a of m. It's magically because this guy go to the front like a factor. And property number 8, que es a repetition, is I repeat because it's super important, is the famous change of base form we used before. Remember, I want to repeat. Logarithm of the any base. Suppose que A is the given base, que maybe is non-standard. Entonces, to compute it by the calculator, or I don't know, you change to the another base, que es standard or no, I don't know. You divide 2 logarithms. This is the most important formula today. You change non-standard. Suppose que you change to a standard as log of x divided by log of a, or ln x divided by ln a. And we use it using this and this calculator. Okay? Okay, let's practice a little bit. Condensing and expand. Because in the test, you see some question like that. But it's extremely easy, in my opinion, no? It's extremely easy. Suppose express as a single logarithm, basic is condensing. Condensing. So we have several logarithms. Suppose example 1 easy. Logarithm base 3 of m plus logarithm base 3 of m. And the question say express as a single logarithm. Logarithmic hm. When it's logarithmic is adjective. When it's logarithm, it's a noun. Entonces, you condensing, apply the property number 5. You apply the property number 5, you condensing in only one. The base should be the same, 3, 3. See, it's 3, 4 or 3, no. So the property number 5 apply only when the base is the same. Otherwise, no. It's m times m. Super. Another more interesting example. Suppose. Why not? Number 2. logaritmo base 5 of 4 plus logaritmo base 5 of x cubed minus 2 plus logaritmo base 5 of 2. Okay. And my goal is expressing in only one single, only one. So you have 3, 1, 2, 3, 1, 2, 3. However, I want to express in only one logarithm. And the base should be the same, of course. And you multiplication. Multiplication 4 times this algebraic expression times 2. And 4 times 2 is 8. Multiplication by x cubed, you know? Minus 2, something like that, right? Entonces, don't forget, this is important detail. Es sophisticated detail, pero it's important. Another parenthesis or bracket here. Remember, when you write this word, and you put, some people, I see every day this idea, log of x. Everyone understand. However, you write f of x like that. You write f of x like that. No, coño. Okay, entonces es mandatory always put the parenthesis. This parenthesis is the parenthesis for this expression. But A multiply this expression now, entonces you enclose another parenthesis or square bracket, whatever you want, different level of the parenthesis to enclose the argument for the logarithm. Okay. This was easy. Let me try another example, number 3. Suppose 3 logarithm base 6 of x plus 5 logarithm base 6 of x minus 6. Okay, condensing this logarithm, in this case only 2 logarithm. And also, I don't want, you're right. Okay, in this case, you apply the property number 5 again, no? Because it's plus, plus is 5. You apply the property number 5 here, so be. And you apply here the property number 5 because it's plus. But you apply the property number 7 also, because I don't want coefficient. The coefficient should be, so you condensing this logarithm in only one, and the base is the same, but you condensing well, the factor in the front here is no, 1 is invisible, right? So you apply the property number 7 que allows this exponent go here, like exponent. Actually is x cubed time, because the plus is time, x minus 6 to the 5th power. And don't forget the last parenthesis can involve everything inside the argument for the logarithm function. Okay, one more of this. This is the property, the magic property that allows us manipulation, the complicated equation, and the complicated word problem that we studied in this chapter. You need to be aware for this situation. Okay. In this case, wow, you apply one more time the property number 7, because I can see here the factor, and the factor fly to the exponent, no? Like, you see minus, just minus property number 6. And property number 6 because of division. Entonces basic is LM, division something, x minus 12, raised to the 8th power, and x cubed. And don't forget the parenthesis or bracket, whatever you want, parenthesis or bracket, either way, enclose everything by the argument for the logarithm function. Do you understand this or no? Yes or no? Okay, let's do it in opposite direction. Suppose I want to complicate your life. Let's do it in opposite direction. Now, I have several logarithms. No, sorry. I have one logarithm. Yeah, I want to expand in opposite direction. So the thing we're doing so far is you condensing several logarithms in only one. No, we're doing opposite direction because sometimes we need opposite direction. So for example, we have only one single logarithm and you expand using several. Suppose one interesting example. Suppose I have logarithm base 5 is given of the x to the 5th power divided by y to the 6th power. And you need to expand. And it's important when you expand, you express it, the powers, okay, 5 and 6, as a factor. So we apply the property number 7, pero en backward, in opposite direction. So you have two expressions, okay. So I write logarithm base 5 of x into this exponent I put in the front as a factor 5. But in this case, division. Entonces, division is minus 6 times log base 5 of y. End the story. End the story. One more example. One more. Suppose number 6. Suppose ln. We have m to the 5th power. We have m to the 8th power. We have x to the 6th power. And we have y to the 7th power. Capital Y. Okay, we expand in 1, 2, 3, 4 logarithm, I suppose, no? The number, so the expression in the top is positive. The expression in the bottom is negative because of the division. So basically, you apply in this example the property number 5, the property number 6, and the property number 7 together. Okay, because we have exponent, the exponent go to the front. Okay, so the first guy is m, suppose it's 5 ln of m plus, because of multiplication here, is 8 ln of m. Now the rest is division. Some students ask me, bueno, professor, pero this is multiplication, pero es multiplication in the bottom, no? Entonces es minus everything, entonces es minus. Minus 6 ln of x minus 7 ln of y. Okay, and this is the definitely the expand. This. Everyone follow me? Do you understand very well or no? Because this is the most important idea for manipulation any equation or word problem using logarithm. Yes or no? Are you sleeping? Yes. Okay, Joanna Cruz. Okay, good. Okay. Entonces I propose you, the student que have no calculator, okay, are in disadvantage now, no? Because I want now definitely the example I start today, the class. Remember the class I start with this example. Suppose 2 to the x is equal to 3. Wow. This is, remember, let me refresh your memory again. We have two kinds of exponential equation. One equation like that, okay, it's easy, because you're solving, because you can express a 4 like a power of 2, x equal 2. This is easy. And you have ugly, nasty exponential equation 2 to the x equal 3. Okay, we cannot do this. No. Okay, but we study logarithmic. And logarithm open new door. Okay? Suppose, hypothetically, I apply logarithm both sides. Log. But what kind of logarithm we use? Well, we're using professor much better standard because definitely I can compute it with the calculator, no? So in this moment, I apply the property number 7. Okay, the property number 7 allow me this exponent go to the front as a factor. So my equation is something like that. Okay, property number 7 allow me this x put in the front as a factor. Wow, fantastic, amazing. Look at that. This is okay. I try to understand this new idea. The erase in this whiteboard doesn't work very well. Work, but in the small. Pero in the big no. Or maybe I don't know. Okay, look at that. Okay. Algebra, intermediate algebra, elementary algebra, we solve this equation. 2x equals 3. How? Well, you divide by 2. X equals 3 over 2. This is a linear equation. This is a exponential equation. It's different, completely different. Exponential equation. Now, when you apply logarithm of both sides, magically, this is magic. You convert this exponential equation in linear equation because actually this is a number and this is a number. Number weird, I know, I understand. Well, this number we can compute using the calculator. Entonces, then I don't care, I get weird. It's just a number. And you divide both sides by log of 2. Log of 2. Now this cancel out. X is equal log of 3 divided by log of 2. Okay. And this is the answer, Professor. One, okay. This is the exact answer. And this answer, nobody understand anything. No, because it's ugly. However, we can do the no exact, so in the real life, we don't care exact answer. I need the approximate answer. We using the calculator to say that this moment you put it here, you change this sign for this sign, gets approximately, and you put it in the calculator. Let me try. Come on. The student can have calculator, try. You put log, so in the displays, you type it log. Open parenthesis, you put 3, close the parenthesis, division, log of 2, close the parenthesis, division. Wow, what the hell? Division, log of 2. Okay, and press enter. You press enter is like an equal sign. And the answer is, I copy the answer, 1.58496.250. Depending the calculator, you have more digit approximation or no. However, in the test, a specification, the amount of the in which you round the decimal approximation. Suppose the majority of tests 4 decimal place I need. 1, 2, 3, and 4, right? See the next digit. Remember the rule of the round. See the next digit is greater than 5. Say 5 or greater than 5. You're increasing 1 unit the last digit. So 49 plus 1 is 50. The answer is 1.5850, no? And this 0, your specification, because I say in the test 4 decimal place. Do you understand this very well or no? Do you understand very well this or no? Yes. Please try to do in your own calculator, Tico, try to do in your own calculator now. One of the students can have calculator, no? The student can have no calculator. Well. Next time you bring the calculator. So we are doing redo again this problem. Okay. And you get the same answer like me, Tico? Okay, super. Okay, let's do it one more. I don't want to say the answer, and you give me the answer. Another problem. Another exponential, ugly, nasty exponential equation. Suppose example 2 is 5 to the 3x equal 8. Okay, well, we're using the imagination, no? Okay. Professor say que apply logarithm both sides. We can. Okay, we can. Let's do it. We apply logarithm both sides. What kind of logarithm? Standard. LOG or LN. Either way, whatever you want. Suppose the student at the beginning prefer LOG. Okay, understand very well. LOG of the expression phi, parenthesis 2 exponent 3x equal LOG of A. Okay, super. Okay, in this case, where I want to apply property number 5 because of multiplication. This is the period, time, and property 7 because I can see also here in the unknown, in the x variable, I see exponent, no? So apply property number 7. So you separate logarithm base 5, no, logarithm of 5, sorry, plus 3x logarithm base 2 here, because this 3x fly as a factor to the front, equal LOG of A. Okay, in this moment, it's obvious that you have the linear equation, no exponential equation anymore. So the logarithm destroy definitely the exponential equation and convert to a linear equation. Okay, now I try to apply the knowledge that we have in elementary algebra and solve for x. So you move logarithm 5 to the right. Subtraction. And finally, see, I want to solve for x, divide both sides by 3 log of 2. 3 log of 2. So we have f alone is equal of a minus log of I divided by 3 log of 2. And we can put in the calculator like that. Yes, we can, but no. I do not recommend this. And one more time, you apply the property for the logarithm. I apply the property number 6 and the property number 7 because I see in a subtraction is -6. We can condense in this logarithm in only one. It's A or 5 because minus the division. And here is the exponent. Entonces, LOG of 2 to the cubic power, ¿no? But I know que 2 to the cubic power is 8. Entonces, yo sé. Okay, do you understand where I come from this 8? Entonces, this is a moment we can do in that way. Pero maybe some students make a mistake because you need to specification more clear the parentheses in the calculator. No. In this case, the display of the calculator in this case is like that. This is display. You type it, LOG. Automatically, the calculator open the parentheses. And doing, guys, I don't want to say the answer. So you type in LOG. Okay, you put it inside the LOG A division 5. Close the parentheses. A division 5. Close the parentheses. I did that part. Now another division. Division what? Division LOG again of 8. Close the parentheses, press enter. Bang, I get the answer. Come on, help me. What is the answer you get? The student can have calculated today. Exactly, very well. The answer is, let me copy. I copy the answer exactly in the I can see in the display of the calculator. 0.226 0.23968. But in the test, I want 1, 2, 3, 4 decimal place. 4 decimal place, this digit is less than 5. You truncate like that, 0.2260. End the story. Super. We are the best. Okay? Well, I have another problem. See, we have 5 minutes. Okay. Another problem more complicated. Any question, guys? So basically, you need to be aware that we have two kinds of exponential. Exponential equation in which you can manipulate both sides to express it. Entonces, you say, bueno, professor, I can do, for example, this easy exponential equation. We can do using logarithm. Of course we can. Of course we can. Pero no necessary. It's stupid, right? Okay, suppose que you apply logarithm. Standard logarithm. LOG. You apply the property 7 now. This exponent go to the front. Immediately, you have, in this moment, linear equation. So x is equal LOG of 4 divided by LOG of 2. Okay. But the professor wants the exact answer. So I need to use a calculator display. Wow. Okay, calculator. Display. I put it in the calculator display. LOG of 4 divided by LOG of 2. Please help me. LOG of 4, close the parenthesis. Don't forget to close the parenthesis. Es 2. Que es the same answer. Que es the same answer que we get using the another idea. Another idea is you manipulate both sides in order to express it using the same base, and automatically without logarithm, we get x equal to. This is one possibility. This is another possibility, more general. Okay. Bueno, let's move on to the last example. It's very, very crazy. Maybe we don't finish, but at least I want to present. Are you tired? Are you tired? Yes. Sorry for you. I am not tired. Okay? And the only guy talking is me, no? You only pay attention, no? I suppose that your word is easier than my word, right? Okay, suppose example 3, heavy, complicated. Example 3 is 0.3 raised to the 1 plus x equal 1.7 raised to the 2x minus 1. Okay, it's obvious that this is complicated, very, very complicated, because we have the base is crazy number, 0.3 and 1.7. It's impossible, totally impossible manipulate both sides. So definitely I understand that you apply logarithm. What kind of logarithm standard? Why not? I want to apply this ln to seek its perfect effective. You apply ln 0.3 1 plus x ln 1.7 2x minus 1. Okay, now you apply the property number 7. Okay, fantastic. This exponent go to the front here, and this exponent go to the front. So we have x plus 1 plus x, doesn't matter, the order. Parenthesis, don't forget the parenthesis. The parenthesis is extremely important, because if you ignore this parenthesis, so you are in trouble, big trouble, no? So 2x minus 1, ln 1.7. In this moment, I have a linear equation, no exponential equation anymore. This is exponential equation, EE, linear equation. You apply like always distributive property, because you consider that this guy is like a number. Number que is weird, I know, but we can use a calculator to compute that. You you apply distributive property here and here. So we have x times ln 0.3 plus ln 0.3 times 1, que 1 is invisible, multiplier 2x times ln 1.7 minus ln 1.7. Again, -1 is invisible multiplier. Now I can see that my variable is located here and located here. So my opinion is try to move the term that contains a variable to the one side. I don't know if left or right. I suppose the right is much better. And the term that do not contain this and this is just numerical, no variable. This is 1.7 to the other side. No, so my equation look like that. 2x, for example, I make a decision that 2x stay here minus x ln of 0.3. And ln 0.3 stay here plus, because it's minus, no? ln 1.7. Okay, super. Okay, now, why not? Factorization. Is there a common factor here? X is common factor. The factor out x, we have 2 ln 1.7 minus ln. And the left, we have exactly the same situation. I don't want to copy again. So this is copy and paste. Okay, entonces in order to isolate x, you divide both sides, you divide this divided by this, right? It's 2 ln 1.7 minus ln 0.3, and this is x, right? You put in the calculator, you can put in the calculator. However, I do not recommend. Okay, guys, time is over. We continue next time. Okay, don't worry. Everyone, bring the calculator next time. Calculator mandatory. So you don't bring the calculator, you don't pass this class. Calculators, do you understand it's mandatory, right? Because without calculator, we cannot compute the logarithm functions and exponential functions. It's impossible by hand using, for example, the regular calculator. Okay, guys, you can leave. Thank you so much for your attention.